Okay, in this video, we're going to solve this system of equation here using the Gauss-Jordan elimination method. And so, let's begin. Now, this video is more of a practice video, so I'm assuming you are somewhat familiar with this method. But if you're completely not familiar with this method, I recommend go to the description box of this video and watch the detailed example. So first, I'm going to rewrite this using a matrix. So I'm going to focus on the coefficients. So 3, -7, 2, 5, dash, 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 and we have is equal to 2 and 11. 2 and 11. And with this particular method, our objective is to get this 1, 1, 0, 0, dash, dash, dash. And whenever we achieve this goal, this value will correspond to x, and this value will correspond to y. And so it's kind of like a puzzle. So we have to apply row operations. So let's do that. Let's rewrite this. So we have 3, -7, 2, 5, dash, 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 2, 11. And what I'm going to do just to get started, I'm going to multiply this entire row by 2. So I'm going to say 2r1. This row, I'm going to multiply by 3. 3r2. And in doing so, I'm going to get 3 times 2 is 6. -7 times 2 is -14. Dash, dash, dash. 2 times 2 is 4. Likewise, 2 times 3 is 6. 5 times 3 is 15. And 11 times 3 is 33. And the idea why we can do this, we're multiplying the entire row by 2 and the entire row by 3, both the left and the right of the equal sign. At this point, I want this piece to be 0, and I can achieve this if I go ahead and say row 2 minus row 1. And that was the whole purpose of doing this. So let's do that. So the first row will remain the same, 6, -14, dash, 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 4. This is where it's going to be affected. So row 2 minus row 1. So row 2 is 6, 6 minus 6 is 0. Likewise, 15 minus -14 will give us 29. 33 minus 4 will give us 29. So we achieved part of our goal. This is 0. Now this is 29, this is 29. So the next step will be kind of easy. I can multiply row 2 by 1 divided by 29. And in doing so, I'm going to get my nice 1. So let's do this here. So again, row 1 will remain the same. 6, -14, dash, 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 4. 0 times 1 over 29 will give us 0. But 1 over 29 times 29 will give us 1. 29 times 1 over 29, same thing, 1. So if you notice, we have 0, 1. We're halfway there. The next thing I want to do is get this piece to be 0. And that's not going to be that bad. What I'm going to say is take row 1 and add 14 times row 2. Because this is a nice 1. And so we're going to get, so row 1 plus 14 times row 2. 0 times 14 is still 0, so we just get 6. Then we do -14 plus 14 times 1 is 14. -14 plus 14 is 0, dash, dash, dash. Then we do 4 plus 14 times 1, so 14. 14 plus 4 is 18. And row 2 remains the same, 0, 1, 1. And so we're pretty much there. We have 0, 0, 1. All we need is this piece to be a 1. And we can do that if we do 1/6 of row 1. So we'll have 1/6 of row 1. So 6 times 1/6 is 1. 0 times a 6 is still 0, dash, dash, dash. 18 times a 6 would be 3. Row 2 remains the same, 0, 1, 1. And so finally we achieved our goal, 1, 1, 0, 0. X is therefore going to be 3. And y is therefore going to be 1. This right here is our final answer, but we did all this work, we might as well check our answer. 3 times 3 is 9, minus 7 times 1 is -7, 9 minus 7 is 2. Likewise, 2 times 3 is 6, 5 times 1 is 5, 6 plus 5 is 11. And if you want more practice, check out the description box for more videos.